Correlation is a statistical technique used to measure and describe a relationship between two variables. For example, finding out the relationship between family income and the grade is example for this. So you can try to find out if there's any relationship, either positive relationship or negative relationship between the family income and the grade. For example, the higher the family income is, the better the grade is, or something like that. Well, it could be the higher the family income is, the lower the grade might get. So, or there could be, instead of just one-way direction, one-way linear relationship, it could be two-directional. Until a certain point, it could be a positive relationship, and after that point, there could be a negative relationship. I've observed many correlations like that in real life. And scatter plot is used to describe, as opposed to histogram we use for the earlier examples. For correlations, because we have two variables, and you use one variable for x-axis and use the other variable for y-axis, we have scatter plot instead of histogram. And scatter plot can be represented by lines. For example, this looks like sort of like, in an ideal perfect situation, it could be straight line, positive straight line. So correlation has three basic characteristics: direction, as I was saying, positive or negative, and a form. A form is linear or non-linear. That could be more like this relationship, or it could be this kind of relationship. And strength is the last characteristic. When there's a strong correlations, the slope of the slope can be very clear, apparent. If it's really shallow slope, you can't really see if it's going upward or downward. Then it means no relationship. Okay. The sign of the correlation tells you the direction of the relationship. When the correlation is positive, the two variables move in the same direction. As one increases, so does the other. As one decreases, so does the other. For example, in this example, it looks like the higher the income is, the higher the grade might be. People with low income tend to have lower grades. People with high income tend to have higher grades. Direction. And when the correlation is negative, the two variables move in different directions. As one increases, the other decreases. As one decreases, the other increases. There are a lot of examples for this kind of relationship in real world. For example, when the temperature is high, coffee sales are low. When the temperature is low, coffee sales are high, something like that. In a form, as I said, linear and non-linear. The relationship between family income and grades is pretty much linear. If you get the middle if you strike through the line in the middle, you know, the median points, then you know you can kind of draw a straight line. And for this too. But sometimes it's not easy to come up with a straight line when you know, when plots are like this. Drawing a straight line might be a little way too off. With this, the data are a better fit with a curved line than a straight line, and you can kind of judge from the look. And strength is about how much the two variables are related. For a strong relationship, as I said, a change in one variable is accompanied by a predictable change in the other variable. For a weak relationship, a change in one variable is not accompanied by a predicted change in the other variable. And what it's saying is one variable and the other variable. It's not talking about which and which. So, yeah. There could be a change in, you know, in this variable. But what if there's no change in this variable? It would be a straight line like this, and that's a weak, very weak relationship. That's easy to understand. But something that's kind of out of ordinary is, you know, when you have a vertical line like this. Okay, you see a change in this variable, you know, if it's a straight line like this, but you're not seeing a change in this variable. So I can have to assume there are two kinds of, you know, if you switch this around, straight line, horizontal line could be vertical line. If you switch the, you know, it's all about how you label the axis. So for that matter, I think the strongest relationship is just going right in the middle, this way or that way. In other words, slope, you know, the strongest relationship between two variables in terms of slope will be when the slope is 1. That's what I think. The ratio of increase for this is equal to the ratio of increase in this. That's when that's the case. I think it's, you know, that means that, you know, the slope is 1. So 10% increase, 10% increase, 20% increase, 20% increase, 50% increase, and 50% increase, something like that. That's when the relationship is the most is the strongest. That's what I think. I might be wrong. Okay. Or -1, you know, 1 or -1. And okay, this doesn't look like it's a strong, you know, correlation, because it's not going in. You can't really, there's no pattern in increase or decrease. It's just a random. And this looks like it's kind of strong, pretty strong, going like, see, 50, and then, you know, it's not quite close to the strongest relationship correlation, but look at that. You get twice as big, and it gets not twice as large, but like, you know, 100% increase and like a 45% increase or 50% increase, so it's kind of large, huh? The correlation gives us a numerical indicator of the strength of the relationship in the two variables. That's what I was saying. The max can only be 1 or -1. And the 0 means absolutely no relationship. See, that's what I was talking about. The slope is, increase by 1, 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 1. That's the max ratio-wise correlation, the same way. Perfect -1, -1, Increase 1, decrease 1, increase 1, decrease 1. Okay. The early example, the correlation between income and grade is 0.65. I don't know how you got this number, but suppose that the correlation is 0.65. It's close to 1, kind of. It's more than half. So, how do you interpret that? That's why I'm gonna do this in what we did in this class. And correlation of -0.86 is definitely more stronger than the other one I just saw. -0.04. That was -0.04 kind of figure, because you can't really see patterns here. Okay, but still you can get the correlation anyway, even when there's no correlation. Actually, there's no correlation. That's the conclusion you have to infer. Okay, and here what we're doing is a Pearson correlation. We're going to be doing two kinds of correlations, and in this class we did one of them, Pearson correlation.